This is Math 2, 9.4 notes. That's Unit 9, Lesson 4. Okay, today we're going to factor using the greatest common factor, which we're going to call from now on GCF. GCF factoring, greatest common factor. Okay, number one is going to be a review from our previous lessons. I want you to multiply the following problem. 3x times the quantity of x plus 5. Okay, distribution, you multiply the 3x times x, giving you 3x squared because you multiply the numbers in the front and add the exponents, plus 3x times 5 is 15x. Okay, what we're going to be doing today is working backwards. I'm going to give you pretty much the answer and you're going to work back to the original problem. Okay, so let's just get practice with it. So let's say I gave you this 3x squared plus 15x and didn't tell you what we had originally and asked you to come up with it on your own. What you would do is look for a greatest common factor. Okay, what I'm going to show you now is I'm just going to expand everything. 3x squared is 3 times x times x. 15x is 3 times 5 times x. And we're going to look for common factors. Okay, so there's a 3 in common, and there are some x's, an x there and an x there. So they have in common a 3x there, a 3x there. What's left over on the first term is an x, plus what's left over here when I take out the 3 and the x is a 5. And that is indeed what we started with. Okay, so that's what we're going to be doing. Eventually they will get easier, just going to take some practice. It will be a little confusing at the beginning. Number 2, 14x to the third minus 42x squared plus 21x. Okay, and I am going to show you different ways of doing it. First way, I'm going to continue showing it using the factors. You break down the 14 to 2 and 7, 42 to 7 and 6, and 6 to 2 and 3. And 21 to 3 and 7. Okay, so I have 2 times 7 and then 3 x's. And then 2, 3, 7, 2, 3, 7, and 2 x's, because it's x squared, plus 3, 7, and an x. And I'm going to go through and circle all the common factors. They do not all have a 2. They do not all have a 3, but they do all have a 7. Do you see that? Okay, and then do they all have at least one x in common, an x, and x, and an x? Now these two have more x's in common, but this one has no more x's, and greatest common factor needs to be common within all of them. For example, these two have 3's, but this one doesn't. These two have 2's, but this one doesn't. These two have more x's, but this one doesn't. So the only thing, the greatest amount of things they have in common is the 7 and the x. The 7x, the 7x, and the 7x. So that is our greatest common factor. 7x times what would give me 14x cubed? Well, what's left over? 2 and x, and an x is 2x squared. 2 times 3 times x is 6x plus 3. Now you can check this. You should always check it. 7x times 2x squared would be 14x to the third. 7x times negative 6x would be negative 42x squared, and 7x times positive 3 would indeed be positive 21x. All right, number 3, 18a plus 27. Okay, factors of 18 are 9 and 2, 3 and 3. 27 is 9 and 3, 3 and 3. So I have 2, 3, 3, and a plus 3, 3, 3, and no a. What do they have in common? They have a 3 and another 3, and that is it. There's no A's in common. They don't have another set of 3's in common or a 2. So 3 times 3 is 9 is what's coming out. What's left over here is a 2A plus what's left over there is a 3, and we check it. 9 times 2A is 18A. 9 times 3 is 27. Okay, number 4. 7y to the third, z to the fourth, minus 15yz squared. Okay, so this one, I'm going to show you a different way. Looking, just kind of glancing through without listing factors. Does 7 have a common factor and 15 have a common factor? 7 and 15, do they have a common factor? No, there's no number besides 1 that would divide into 7 evenly and 15 evenly. Okay, now there's 1y here and 3 of them here, so they have 1 in common. There's 2 z's here and 4 there, so they have 2 in common. So yz squared is your GCF. You could list everything out if you'd like we did over here. I'm trying to show you how to do without. Okay, now this next step, again, it's just a different way of doing it. Divide everything by what your GCF is. So 7's left behind, subtract your exponents. 3 take away 1 is 2, y behind. 4 take away 2 is 2, so z squared is left behind. Minus 15, y's are gone completely, and z squareds are gone completely, so it's just 15. Let's do a check. 7 times 1 is 7. Y times y squared is y cubed. And z squared times z squared is indeed z to the fourth. Okay, 1 times negative 15 is the negative 15. And yz squared times no variables are going to be the yz squared. So indeed, it does work. Okay, number 5. 4x to the third plus 12x squared plus 4x. Okay. When you look at this one, again, let's try using our shortcut where we're not listing all the factors. What goes into 4, 12, and 4 evenly? 4. 4 is the largest number that's going to divide into each one evenly. There's 3 x's here, 2 here, and 1 there. They have at most 1 in common. When you're looking at your GCF for your variables, it's always going to be the smaller exponent. So we divide everything by 4x and reduce. 4's are gone. X cubed divided by x to the 1, subtract the exponents, you get x squared, plus 12 divided by 4 is 3. Subtract the exponents, you get x, plus 4x and 4x reduce. They don't disappear. That leaves behind a 1, and that there is your answer. Let's check it. 4x squared times x, 4x times x squared is indeed 4x cubed, plus 4x times 3x is indeed 12x squared, and then 4x times 1 is indeed 4x. Okay. Number 6. 18, x to the third, y to the fourth, plus 24, x to the fifth, y squared, minus 12, x to the sixth, y to the fifth. Okay, so taking a look, and that closed parentheses should not be there. So I'm going to show you one last way of doing these. And before I go any further, take a look. Sometimes your GCF has a number and a variable, a number and a variable. Sometimes your GCF is just a variable. Sometimes it's just a constant. So it does change depending on the problem. Okay, largest number that can go into 19, 24, and 12. Sometimes it will take some practice. If you're not sure, then list all the factors and circle the ones they have in common. Okay, so looking here, it looks like it could possibly be maybe 6. Okay, so let's try it, and I'll show you some tools in class as well as on how to figure out if that GCF is correct. Okay, x3, x5, x6, the most they have in common is x to the third, and I told you earlier it's always going to be the smaller one. y4, y squared, y to the fifth, the most they have in common is y squared, which is indeed the smallest exponent. And without dividing, you just go through and fill in. There's 1, 2, 3 terms, so there's going to be 1, 2, 3 terms in here, and what times what. 6 times what is 18? 3. X to the third times what is x to the third? Nothing, because the x to the third is already there. Y squared times what is y to the fourth? Remember, you add your exponents, so y2 and y2 would give you y to the fourth. Plus 6 times what is 24? 6 times 4. X to the third times what is x to the fifth? Remember, you add exponents, so 3 plus what is 5? 2. Y squared is already y squared is taken care of. Don't put another y. You're going to mess it up if you do. 6 times what is 12? 6 times 2. x3 times what is x to the 6th? Remember, you add exponents. 3 plus what is 6? That would be 3. Y squared times y to what power would be y to the fifth? So 2 plus what is 5? That would be 3. And then you check it. First off, do any of these have a GCF? Because if they do, this GCF was not correct. 3, 4, and 2. No, there's nothing in common. They do not all have a y. They do not all have an x. So this looks good. And we have to distribute to double check. So distribute the 6x cubed y squared to everything. 6 times 3 is 18. X cubed times nothing is x cubed. Y squared and y squared is y to the fourth. Okay, plus 6 times 4 is 24. X cubed and x squared is x to the fifth. Y squared and nothing is y squared. 6 times negative 2 is negative 12. X3 and x3 is x to the sixth. Y squared times y to the third is y to the fifth. It does indeed work. Okay, number 7, I'm going to have you try on your own. Minus 80z to the third plus 112z squared. And then we're going to do 2 more in class. Okay, that is it for this lesson.